Right. Hi again. It's been a while, and I've been busy with the core, and I realized that all this fancy front end stuff, and I happen to have a touchscreen now. I got my computer back, and it's a pleasure to work with this. Only eye candy, obviously, but I think it works really great. It's a shame there's no sound coming out of this machine yet, but there will be hopefully before Christmas we have something coming out of this. So this episode will be quite code heavy, I think. I think that I should just explain a bit about the front end stuff, and then just jump into the how the everything works in the core of the timing and everything. So about the front end, I can say that I said it before that I looked into Pinya, and I think that that could really be a way forward. So if you are a front end person and you want to contribute and you don't know Pinya, I just took this course myself at YouTube, and I can really recommend it. And all the communication between the backend and front end of SavingCaustic will be in standard formats like JSON and stuff like that. So there will probably be a REST API for doing the heavy lifting, and then for the fast stuff like altering parameters and stuff like that, there will be WebSockets. But I think you need both, and a REST server will be the first stop in that. So that's actually one of the things that I will look into in the coming weeks. Specifications for the REST protocol driving this. So with that said, I know a lot of you have asked how can I help, and this is an episode where I can actually come with some suggestion on how you can help. So what I would like to do now is to just walk you through from a technical perspective how this is all working, and I do that by I made a new commit and a new file in the root directory called notes. And as you can see, I have also a new name for the project, and that's just because if Caustic 4 is getting launched, or the old developer thinks that come on, stop using Caustic here. The playhead is the name that I think is quite catchy, and also double because it's the playhead in the tape recorder, and also you have songs in your head. So, and if anyone has another name suggestion, please feel free to comment. So without further ado, let's walk into the framework, the core of the not framework, the application, the toy, the gizmo, not framework. Okay, so the semantics here. Everything related to the timing is driven by the audio card requesting more samples. And whether that's like 2048 samples or really small, that chunk of samples is being divided into 64 samples. And that is the smallest time unit that the core knows about. If you want to go below that time unit, you need to be inside your synths or stuff like that in the rendering process. So the core, when it does its things, it's 64 samples. That is approximately with as you can see, the sampling frequency is now 48K, and that is because it seems like a standard in mobile platforms. So that's like 750 times per second a render request is being made. And this is not related to the audio buffer size. You can have a really big audio buffer size if you have like slow devices or just shitty hardware. You can have a really big audio buffer size, but that is being sliced into these 64 sample frames. So that frame generates a pulse, and the pulse is like a frame is generates actually a fraction of a pulse. Sorry, my son is coming here. So anyhow, so the pulse counts up to from 0 to 95, and the pulse is dependent on the frame, but also the tempo. And when you roll over from 95 to 0, that's 1/8. And why are we doing all this stuff? Much of this is because I really like that you can use caustic also as, or not caustic, the playhead, as a way to, without having anything running, like without having a pattern running or a song running, there is still pulse in the eventers and in the effects. So that's, so the pulse generates an eighth, and that eighth then drives the tick, or actually a bit fiddly there. It's complicated, but you can see it in the code. Because we need the eighth, and that is the pulse is responsible for that, and the pulse does not care what time signature it is. It could be any time signature. A pulse is always a pulse. It's goes from 0 to 95. You can't have a time signature in like 7/16. Unfortunately, I'm really sorry for that. I know you want it, but 8 is the lowest. So you can have like 6/8 or 9/8 or 11/8, but you can't go beneath 8. So the pulse is not dependent on the time signature of the pattern. And then you have the tick, and the tick ranges depending on the time signature. Normally you have 4/4, and then the time signature is 192 times 4. For this is pulses per quarter note. So 192 times 4 is like 768. And if you have 5/4s, then it becomes higher, etc. So the tick can go beyond 768, and they may also be swung. So if you have a swing either in the global swing that you set, or you have a override with another swing in the rack, and I changed that. I think that's better to have an override in the rack and not in each pattern, because I think that it's more like if you have like a bass that you want a bit less swing in. I think that's just my idea of it currently. Anyhow, and then you have the clock, and the clock is not as high resolution as a tick. It's 24 pulses per quarter note, which is the old MIDI standard, and you can output that on the MIDI bus. And I also think that would be really fun to have more MIDI out coming, or actually have some MIDI out coming out from Caustic. There's nothing coming out in the old app, so I would like to have some clock coming out, and also that you have like a synth that is actually just a MIDI out synth. So what you play or record goes out on the MIDI bus. So anyhow, I will now walk you through these files, and also how you can test this. So what I would like from you is to look into this core, and if you find anything that is just bonkers or really bad, or let me know and give me a suggestion on how it can be made better. I have used Hungarian notations in sorry, in some I should take a glass of water, hang on. I have used Hungarian notations some places, and you can think that is a bad idea. I think it's quite okay, because I haven't used it for the playhead, because it's so obvious that many objects have the reference to the player engine. The player engine is like the main class of the background process. So the player engine is doing all the round robin guy who just makes everything work together. And apart from that, you have an age, for example, this pattern player. You see immediately that it's an object. So how does this work? You have a test folder where you can run different tests. For example, if you just php porgy, php, it quite quickly generates the porgy wav, play porgy, and you hear that's that old Toto song, and also with some effects. So how does that work? Well, it requests a test writer that we don't really need to go into. What that does, it gets initializes a WAV file so that we can save it to disk. But the interesting here is that we can get a reference back to the player engine. And now we can set up a rack and get a reference to the rack and also to the synth in that rack. And now we create a pattern. Just, this is just silly characters, and then I'm using some PHP script to generate the actual pattern data. And note now that this is also for front-end people, that the pattern that is being the edit that is in a read-write mode, like you can edit, it's optimized for the front end. So it has an ID, and the node has a length and stuff like that. And then when you load it into the pattern player, it gets converted to a format where it doesn't have to be an ID. It has to be ordered in time, and there is a note on event and there is a note off event. So there is no length, and this just makes everything a bit easier for the engine to work with. And at the same time, you have the other format in the front end. So that's a conversion. You can't go back from the like compiled format back to the JSON format. So the JSON format is like read write, and the compiled format is like a immutable, that just for the player engine to work with. So I think that's great stuff for the front end people who want to make an editor and just use IDs and length and stuff like that to make this pattern editor. And then we have some other stuff that we need to know about the pattern. We have to know how many bars is this and what time signature, and etc. And the grid is just what's the viewport when we look at this. What should we look at it in from a 16th perspective? Is you have the same setting. I think that setting is for each pattern. I could be wrong. Anyhow. And as you can see, this is JSON encoded, and then you have this rack method that it can accept a JSON object and just compile it into a pattern that it can play. And then we have some swing, and this is in clocks. Since the swing is also running when we're not playing, it makes more sense to have this unit in clocks rather than ticks. So 12 is, then the cycle is 24 pulses per quarter node. So this is the whole swing cycle is an 8th node, which means that you are moving the 16th node. So this 12 here corresponds to the 16th swing in caustic. If you want to make an 8th swing, it's 24. Okay, and then we load an effect and we set some parameters. And what I want to do is that I want to have an equal process or format for setting parameters in effects and in synths and in eventers, and possibly also the player engine. So there is params abstract. So this is like just an abstract class. What I don't like with this is that it's so stupidly simple in PHP since it's not strongly typed. Obviously, I mean most params are floats or integers, so I think that should be probably should be set param, and then possibly if you want, for example, set a waveform to this, set param string waveform like that. So I think that should be added like a string, so you can get a better type, so you don't have to cost back and forth. So anyhow, and then you have a new thing here, the tape controller, and this is like a state machine for responsible for if we are stopped, if we are stopped, if we are about to stop, if we are playing, if we are about to play. So here we are in this test script, we are asking the player engine to respond to a play key press. So for example, if we already are playing, then we maybe should pause, etc. So that logic is all inside the tape controller that you can find also here in the core. Everything that's essential is here in the core. Yeah, you can look into that state machine, and that I'm not very used to writing state machines, but you can look in if you want to scream, just come with a suggestion on how it can be made better. And here we render. So instead of the audio sound card requesting data, we are rendering 215 times. And then we're setting a parameter, increasing the feedback from what it was, increasing the feedback, and we're stopping and we're rendering some more, and that is what you hear. So all right, so let's dig into this. If I just walk you through this, because it isn't that complicated. The player engine is a lot of getters and setters here that could possibly be moved to or used the abstract class. And here you have some parameters that you can set, and then you have a lot of methods for the rack is really just a host for the eventers, the synth, and the effects, and also the mixer, the rack mixer, where you have the EQ and pan. And why you do that, why you don't have like a master, separate master, because each rack is being processed in a render pool. If you have many cores in the CPU, you're processing many racks at the same time. So it's better to have the IQ in the rack than a separate single mixer unit. All right, so here is the really main thing. And as you can see here, we are we are always, no matter rack render size is constant, defined to 64. So whether the audio buffer size is, we will always loop inside here. So here is the outer loop. What we're doing first, if we need to know if there's a clock reset, and then we do stuff for that, and then we do the actual rendering. So just before the rendering takes place, we look at, has any new MIDI messages come come in. Has anyone pressed the MIDI key? Then we need to, catch that and push that into the rendering. So hopefully that will generate a really low latency when playing with a MIDI keyboard. And here you can see that we have probe new clock. So this line is always running, right? Since the clock is always running. And as you can see here, if we are playing, then we should check if there's a new tick that needs to be processed. And here's a name ambiguity. I think that's because you will get confused. What about new tick? It's because the thing is that since we are also doing swung, we are taking an event in the compiled pattern, and then we are adjusting the event time based on the swing. The swing always generates a delay. It never generates the inverse delay. So and then we are saving that delayed time in a buffer. So we know that, okay, we know when to execute that rack. And that just makes it a lot easier. We don't have to check constantly. And then this does the actual rendering of 64 samples. And then we go back and do another 64 samples. And yeah, then we do some of the stuff. Here's the mixer. And then when we're done with everything, we do this frame turn. So okay, we are now accepting that we have, based on, we came here and now we are doing the frame turn. So we're doing that frame turn after the processing. And as you can see here, it's also, that is taking some effect. So actually the rotator, the frame turn is returns a boolean. So if there's a new 8 coming in, then we should pass that into each rack. And when we're done with doing that for all the audio buffer, whether how big it was, we bring that back to the audio buffer to bring it into the real world. And in our case, to a WAV file. And here you can see a function called test render. This is not longer used, so this is actually for me to delete, because we have a new file, so that should be fine to delete. And the MIDI is obviously not, it's just a mock-up currently. So, and the rotator is really small. It deals with the frames, as I said, and generates that pulse up to 95, and when it rolls over, it sends a signal to all the racks that it has, an 8 has passed, do what you need to do. And I mean, it's two things, because the racks will also be notified for any clock coming. So there's two things actually. So there might be something that I need to adjust here, that it's ambiguity here. Okay, and then we have the rack, which just hosts everything. It hosts. We have several. The layout, the design is that we have several different tiny racks with each rack holding a synth. Before that synth, we have eventers that can process MIDI, and some effects that can process the audio after the synth. So this is just a host really, and it also hosts the pattern player. That pattern player is also really central. So Please check these out, and if you think they are insane, just super badly written, or not being able to, you can't port this to C, or you need to just make these adjustments to make it easier to port to C, let me know. Another thing that is interesting, at least for me, because I spent some time with it, is that if you look at these files, there's a math sketch. I think you can. Hang on. I loaded from here's the math sketches. Yeah, there we go. So here we have the which I struggle quite a lot with. So actually, since I now calculate the swing movement when I find the unswung event, because earlier I had that problem that I calculated the in forward in time, but then when I reached that forward in time, the swing has changed. So the solution is that I just need to take that time and swing it. Just realized the thing. Hang on. Something I need to do. Yeah, I need to make a note here. I realized I need to make an array out of that because you can actually swing one note forward in time, and then really close to that note you have a new original note. You have a new note that you will probably miss. Yeah, that I need to fix that. Anyhow, so this is the curve for tick to time. So what I mean is, what do I mean with this? You have the unswung. Actually, let's do this in swung. Unswung to swung. And it's quite simple. You see, that's like, yeah, it's a sine or a cosine, but it's flipped. And then you have the other thing when you're doing recording in a swung pattern, and you're doing recording with your MIDI keyboard. And how should the recorder know how to place that? Because if it plays that when you play it in time, then it will also add swing later to that time when you press it, so it will sound awkward. So you have to like calculate the ante of the swing, and that is when you do the integral of the swing. So here, for example, with the 66 swing, you can see here that 90 goes. This is the swing cycle. So 90 degrees of the swing cycle, it should be pushed to 120. So if you now press a note on the 120 in time, that should be placed back to the 90 tick. Are you with me? So it's a bit, but it works fine. So if we rise we can rise the swing to, for example, 1.9, and you see that they are all affected. Yeah, so you can oh, that doesn't, yeah, so you can see that it tilts a bit. And here is also math for, I want to have parameters, and I've said it before, so that's coming. I shouldn't shout more about that. So feel free to dig into this code, and feel free to check out the test scripts that is here. And some of them I've removed because I just wanted to make a clean slate. And if we take that tooth track, you can just look into that, how that looks as a final thing. We set some tempo, and we set some swing, and we set up rack, and we set up another rack, and we set some parameters for that first subsynth or subreal synth. And then we place an eventer on my rack 2. Yes, that is, yeah, exactly. And then we set up a third synth. So on the third synth we set up a subreal. Let's see if we set some parameters to that. Yeah, here's we set some parameters to the third synth. And then we render, and then we start. Press the play, and we render, and press the stop, and we have some silence. So that's what you hear when you do them. And when doing this, when like rendering this, it takes quite much time. So it would be fun to see if we can build all this in C now and see what the time would be, because it's 7 seconds long, but there are no reverbs or anything, so we need this to be executed in way less than 7 seconds. It should be executed in like 1 second. But that's probably not a problem. I would estimate that it's like 100 of this, so it's 0.2 seconds. Okay, but I should stop talking, and next thing I'll do is I will write some API for the communication between the front end and back end. And I leave it up to you to just look into this code and join the Discord channel. I post a comment in the Discord channel about I post a comment to the Discord channel, and I also post a comment because a guy told me that someone has written a reverse engineering of caustic files in Python. I don't know Python, unfortunately, so if anyone knows it, I will post that comment too, so that link too. So I need to take a break. See you guys.